Now let's find the limit of a function by using the formula. Now, for a real valued function, this is defined. Okay, we have to find x cubed minus x over x plus 1 as x approaches -1. Now, the initial problem that you'll face over here is that when you input -1 in place of x over here, what would this become? Well, x cubed would become -1, right? And x would also become what? -1, right? And then the denominator, that becomes, x becomes -1 plus 1. And that equals 0 by 0, right? So you can solve this. But you have to convert this entire thing to a form where you can apply this limit without it being undefined, right? So you can, there's one way of solving this, that's by the L'Hopital rule, but that is not in the scope of this chapter, right? So you need to find another way, and that is by simplification. So you take x common from the numerator and you get this, right? Now, what you have to do after that is you have to apply the algebraic identity on this bracket here, x squared minus 1. You all know that a minus b into a plus b is equal to a squared minus b squared. So you can treat x squared minus 1 as x squared minus 1 squared. And that can be written down as x plus 1 into x minus 1 by this same identity, right? So that's why you have this. Now you can cancel out this x plus 1 and this x plus 1. And so you're left with this, right? And once you apply the limit of -1 over here, you get this. And this is not equal to 0. This is equal to 2. And so you found the true limit of the original function as x approaches -1. So you have to be very careful in solving questions about limits, as in many cases it will be equal to 0 over 0 or infinity or something, but in reality it isn't. You have to simplify it.